Assalamu alaikum to another lesson of ICT with Mr. Mudathir. We spoke earlier about system life cycle and we discussed four of the phases that includes analysis and then design and then development and testing and then implementation. In this lesson, we're going to discuss documentation. So let's get started. Documentation. Once the new system is fully developed, a considerable amount of documentation also needs to be produced for. We have two kinds of documentations. One that goes for the end user, which are the users that are going to use the software, and then the next documentation is for people who may need to modify or develop the system further at some later stages. So the first one is a documentation that uh, uh, explains how you can use the system for the users who are going to use the systems. They could be doctors, they could be employees, they could be teachers, they could be students. And the next one is for people who may need to modify the system later on. And those people mostly are system analysts, IT people, programmers, and so on. Yeah. So let's get to know each and every one. What exactly is inside of each and every one? The first one is user documentation. This is designed to help users to learn how to use the software or the system. This can consist of any of the following. The first one, it has how to load, install, or run the software, how to save files, how to do search, how to sort data, how to do print outs, how to add, delete, or amend records. Amend means fix. How to delete, add, delete, or amend records. And the record is part of the database. Yeah. A record is one part of the database. Yeah. Next is the purpose of the system or the program or the software package. Limitations of the system. Now, what do we mean by limitations of the system? Usually in this part, an IT person or a programmer explains what is there that is not included in the system. For example, if you have a security system that takes or allows people to get into a building or to get into a classroom with a fingerprint. Now, the fingerprint usually has security issues. It's not a high recommended or highly recommended sort of a security system. So maybe you would mention that this system does not have a face or a facial recognition system, a face recognition system. So you mentioned the things that you didn't implement or you didn't design in the system, or maybe something that may be included later. Yes, screen layout is basically screenshots of all the layouts or all the screens and the entire software. You take screenshots of all the screen layouts and you explain each and every one. Print layouts, whatever you have reports that later on you can generate. You have an explanation of that. Hardware requirements. Hardware requirements basically is that when you tell a user that in order for this software to work, this software needs minimum of 4 GB of RAM. And we have that in games, in apps, and so on. That's hardware requirement. Whether it's a RAM capacity or a software, sorry, or a processor capacity. For example, some softwares do not work on i3 processors. Yeah. Software requirements. What do we mean by software requirements? It means that the software that is needed for this software to work. For example, some software do not work on Windows, so you can recommend that they have an iOS. Some softwares only work on Windows, and some softwares work on Windows 7 and above. That means if you have Windows 7 and above, Windows 8, 8.11, Windows 10, Windows 11, this software will work. But if you have Windows 2000 or 2002, this software will not work. So this is the meaning of software requirements. Sample runs. You would actually run the software and you would give them samples of that. Error handling and meaning of errors. Now, how you can handle errors and what is the meaning of each and every error. Sometimes when you're working on a device and suddenly sort of a bug happens or maybe the software crashes and it gives you a code. Now, if you Google that code, it will tell you exactly what is the meaning of error. So you can include all the meaning of errors that you have in your software. Troubleshooting guide and helpline and FAQs. Troubleshooting means when you have an issue with any software or hardware, and you're trying to figure out where that error is coming from. Maybe the RAM is broke, maybe the hard disk is broke, or maybe the Wi-Fi is not there, or maybe the Wi-Fi needs a reset. This process is called troubleshooting. When you have an issue and you're trying to troubleshoot or figure out where the issue is rising. Helplines and FAQ. FAQ is short for frequently asked questions. You'll come up with questions about the software and you will provide answers with that. So it's either this or that, or all three of them. Again, you have also you have how to log in, how to log out, tutorial, how to use the software, error messages, meaning of error messages. Again, we explained that at the top, and glossary of terms. If you use any terms that maybe it's not included in the English language, then you can provide them in the glossary terms. For example, LO. I used LO in my software, and LO is short for log on, for example, or LI or SI, sign in. IT people are very fond with using abbreviations, so that could happen. Now, the next type of documentation is technical documentation. Now, in simple words, technical documentation is used. It's meant for IT people, so that, for example, if you're working with a company and then later on you decided that you want to switch your job or you want to leave your job, and then the company, what is the company is going to do? You are the person who is responsible about the software. Now they want to hire a new person, right? So this new person looks at the technical documentation so that they understand how did you design this software? How did you get to the point where the whole organization or the whole firm is working with that software? So technical documentation is designed to help programmers, analysts to make improvements to the system or to repair, maintain the system. This can consist of the following. It doesn't have to be like you're resigning. It could be people who come after you so that they can make updates or upgrades to the system, right? So what is in the technical documentation? Program listing or codes, the code that you use to design the software, programming language you use, which language, whether it's Python, C++, whatever language that you use, you can include that. Program flowcharts, algorithms. Algorithms is basically like a computer program. System flowchart, purpose of the system or the program or the software, limitations of the system, and this one is common between the user documentation and the technical documentation. Input formats, hardware requirements, software requirements. Again, those two are common. We have them in the user documentation. So if when you're designing the documentation, you can just copy and paste those two, right? Minimum memory requirements. For example, this software requires at least 500 GB of hard disk drive in order for it to be installed and to work properly. All right. Known bugs in the system, list of variables you use, X, Y, and so on. File structure, the length of the files. Remember, we studied the file structure, the length of the file, the types of the file, and so on. Sample runs. This is common in the other type of documents. Output formats, validation rules. Which validation did you apply on your system, and meaning of error messages. Now, this is it with the stage before the last, which is documentation. Yeah, there are only two types: user documentation and technical documentation. Now, the last phase in the system lifecycle, and you can take a deep breath. We have gone a very long way, and now we are at the end of our journey. Evaluation is the last stage of the system lifecycle. Let's get into it. Once a system is up and running, it is necessary to do some evaluation. Now, at this stage, everything is done. You designed it, you analyzed it, you designed it, you tested it, you implemented it, you created your documents and everything. Now the system is working and life is going really good. They're using the new system and everyone is happy. It's so fast, it's so nice, neat, and clean, and it generates results faster. Now I want to evaluate. Yeah. Now at this point, you're going to do evaluation and carry out any maintenance necessary. The following is a list of some of the things considered when evaluating how well the new system has worked. This can ultimately lead to redesign of part of the system. At this point, if your evaluation, like while you are evaluating, is it working good? Is it fast? Is it Is it work? Is it reliable? Yeah. If you have any issues, then maybe you will get to a point where you need to redesign part of the system. If there's a strong evidence that suggests changes may be needed to be made. Yeah. How are we going to do evaluation? We're going to compare the final solution with the original task. We're going to identify any limitations of the system. What is there that we may need to use and it's not there? Yeah. Identify any limitations. Identify any necessary improvements that need to be made. This is very clear. Evaluate the user's response to using the new system. I'm going to actually go to each and every employee and I'm going to ask them, how are you finding the new system? Do you like it? If you don't like it, what is there that we can add? What is there that's annoying you, or maybe you find it annoying, and so on. Compare test results from the new system with results from the old system. I'm going to compare results. Am I getting the same results? It has to be the same results, right? But then the new system must be faster than the old system, all right? But both of them produce exactly the same results. 1 + 1 = 2, right? Whether it was paper-based or computer-based, both of them have to bring the same results. But then when you're using calculator, you calculate faster. Yes. Compare performance of the new system with performance of the old system. Now, when we say performance, we mean accuracy and time. Yeah. Is it very accurate? 1 + 1 = 2, so it is accurate. And performance also means time. Is it faster? If it's faster, then you did your job, right? Observe users performing set of tasks. Now I'm going to go sit next to random employees and I'm going to observe them while they are using the system. Yeah, the new system. Measure the time taken to complete tasks. I'm going to measure the time. Is it faster? Interview users to gather responses about how well the new system works. I can sit down on an interview and take their feedback. Give out questionnaires to gather responses about the ease of use of the new system. Now, the book is just reviewing things that we already know. We already know what an interview is. We already know what a questionnaire is. We already know how to gather information via interviews or questionnaires or so on. Some results from the evaluation may lead to two things happening. Okay, I'm done with the evaluation. What could happen next? Two things could happen: update of the hardware or update of the software. Update of the hardware happens, it could happen because of feedback from the end user. New hardware comes on the market, necessitating changes. For example, uh, cell phone companies are um, releasing new cell phones every 1 or 2 years, right? So in 5 years, most of the cell phones that we have are they become very old, and we need to change them. So new hardware comes on the market. The same with computers and laptops. Yeah. Lastly, changes within the company require new devices to be added or updated. If I hired more 100 employees, I'm going to have to expand the system, right? So changes within the company could lead to hardware updates. Okay, update of software could happen also because of feedback from the end users, changes to the company structure, or how the company works that may require modification to the software. Lastly, one of the reasons that could lead to software update is changes in legislation that may require modification to the software. Now, if the company changed their rules or their policies about any of the processes that happen in the company, I'm going to have to change set of the software, how the software works. Well, that is it, guys. With this, we have completed the entire system lifecycle unit, and I hope you guys um, learned the entire unit. It's one of the longest theoretical units in the IGCSE, but then it's fun because uh, you actually learn something that you can implement not just in while creating softwares or analyzing something. You can also think about this as like a lesson that you learn in life. If you have any issues in your life, you can analyze by asking questions, interviewing people, sit down with them, collect more information, and then you can try and find out the solution by designing. If you're an IT person, in real life, you can come up with a logical solution to whatever issues that you have, and then test your theory. If it's a software, you'll design a computer program and then you will test it, and then you will implement it, and then you would create documents documenting every single step that you have while creating the software or fixing the issue or rectifying a problem. And then lastly, you evaluate. After implementation and documentation, the last step is to evaluate. Now, evaluation is the last step or stage in system lifecycle. I'm so happy that we're done with this unit. We can just learn and then put it behind us, and then if we have any assessment, we have these videos. We can get back to them whenever we want. The videos are sort of a fun way to study. You don't have to sit down on a chair and you have a table in front of you and then you have books in front of you. You can just play those videos and let your mind flow with the lessons. Well, that is it for this unit, guys. I'll see you in other units, inshallah. I hope you study really hard and inshallah you'll get high grades. Thank you very much.